Hello everybody, I am Dr. Shafiq Fauzi Kamal Zaman, again delivering you another data communication and networking lecture. So today we will cover our second part of Module 11, IPv4 Addressing. So thank you very much for your support for my video so far, and hopefully you can keep on continuing with my video later on. So I would like to thank everybody for your like and subscribe. So for those who haven't subscribed to my channel, please do subscribe for more latest video later on. So again, this course is for our University Data Communication and Networking lecture series online. So most of the students here are my students in the university. In case you have any questions, you can about our course provided in our university, you can ask us in our comment section. And for those students in our university, don't forget to fill in your attendance as a part of your lecture attendance in the Google form provided in the description. Okay, now let's continue again with our lecture. So today we will continue with Module 11 IPv4 Addressing Part 2. So last time in our last video, we focused on how IPv4 addressing works. So today I will focus on subnetting an IPv4 network, and also for performing a VLSM calculation for your any subnetting project that you want to do. So let's start with our first task, how to subnet an IPv4. So in order to subnet an IPv4, okay, this is the case where you have a host address and a subnet mask. Okay, you are given a host address and a subnet mask. So firstly, you need to get is the network address of the host address. So in order to get the host address, first you need to look at the host address and the subnet mask in binary. So when you look at the host address and subnet mask in binary, you will see these two relation of those addresses. And when you add those binaries, you will get the network address. So this is the network address for this host address. So getting the network address is important since you are going to subnet the network according to the network address. Means you want to split the network into a lot of smaller networks. So basically, what we do here is that we define the network portion for the network address. So in this case, the network portion is this bits. Okay, so 24 bits involved as a network portion, and 8 bits out of the IP address is as for the host portion. So basically, the address here is a /24 address as the prefix. So next, when we want to subnet the IP address, the network address, okay, into a smaller network, so you look at the binary as well. So when you subnet, okay, you need to pay attention on the network portion and host portion. So basically, our network portion is 24-bit, okay, so our host portion originally is 8-bit, but here we want to split it into two, for example. So in order to split into two, we have to borrow 1 bit. Why? Because 2 power of 1 bit, okay, 2 power of 1 is 2. So you get 2 subnets if you borrow 1 bit. So when you borrow 1 bit, the subnet mask will change into 255.255.128 because 1 here is becoming the network portion. So here is where we have your subnet network portion, and your remaining host will be 7 bits. So here your subnet bits, okay, the bits that borrowed for your subnet is 1 bit. So the number of subnetwork that you will have from this network address is 2 power of 1, which equal to 2, and your host bit right now, okay, will become 7 bits. and the number of usable hosts that you have is 2 power of 7 subtract with 2, which is 126 hosts. Okay, what does it mean by subtract with 2? Means that this 2 hosts here is reserved, 2 address here is reserved for network address and for broadcast address. So to summarize this, basically we will get, okay, by subnetting this, we will get 2 subnets with 126 usable hosts for each subnet. So right now, our prefix here will be changed from /24 to /25. So it's as easy as that. So next, when we look at, okay, the subnets that we have, okay, we will have 2 subnets, okay, starting with the original network address here, okay, 192.168.1.0 with prefix new prefix 100/25, and the second subnet will start from 192.168.1.128. So how do you get this number, this value as your second subnet? So basically, we will get it through what we call a magic number. So the magic number, you can get it by the rightmost bit position for your network portion. In this case, your bit position, the rightmost bit position for your network portion now is 2 power of 7, starting from the right here, which is 2 power of 0, 2 power of 1, 2, 3, 4, 5, 6, 7. So the rightmost bit here is 2 power of 7, so your magic number is 128. So basically, from the original network address, you just add 128, okay, to the network address, and it become 192.168.1.128. Okay, from here you can get, okay, from here you can get your broadcast address for your previous network, subnet 1, and the range is between the network address and the broadcast address. And if you add another 128, it will become 256, but we don't have 256, so we stop at 255, which is the maximum number for your subnet. Okay, so we have completed the subnetting process here. So let's try and look at another exercise. So right now, okay, we have another requirement here. You are given a host address 192.168.1.1 with prefix 24. You need at least 3 subnets with 60 usable hosts each. So let's take a look at your host address and your subnet. So your host address is 192.168.1.1, and your subnet mask is 255.255.255.0. You need now is 3 subnet. So let's take a look at the binary here. So when you end the binary, what you will get is your network address. Okay, so your network address is similar as the previous one, 192.168.1.0. So here, your network portion is the first 24-bit, and your host portion is the 8-bit at the back. So this is, we can say it as a /24 host address. So when you got the host address for 192.168.1.1/24, when you get the network address, okay, the network address will be 192.168.1.0. Okay, this is the subnet mask for /24. Okay, and this is the binary. So we are going to borrow 2 bits in order to create extra subnets for your network. Why do we borrow 2 bits? Okay, so basically 2 bits, we borrow 2 bits because 2 power of 2 bits, okay, 2 power of 2 is 4. So you can create 4 subnets by borrowing 2 bits. So when you borrow 2 bits, okay, the new subnet mask here will become 192. So now your subnetwork portion is the 2 bits, okay, the 2 bits here, okay, and then the remaining host portion is only 6 bits left. So you can summarize it as the subnet bits that you borrowed is 2. The number of subnet bits that you borrowed is 2. The number of subnetwork that you have is 2 power of 2, which is 4, and the number of host bit available is equal to 6. Okay, and the number of usable hosts that you have is 2 power of this 6 subtract with 2, which is equal 62. Okay, again, these two here representing one reserved for network address and one reserved for broadcast address for all these subnets. So you can summarize your subnetted network as 4 subnets with 62 usable hosts each for each subnets. Okay, so now instead of /24, your network now will be defined as /26. So now let's take a look at your subnets. Okay, we will have 4 subnets. So start with the original 192.168.1.0. Okay, how do you get the remaining network address? So remember the magic number that I introduced last time. So your magic number here is the rightmost network portion, which is 2 power of 6. Okay, starting from the right, 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5, and this is 2 power of 6. So the rightmost network portion, which is 2 power of 6, is equal to 64. So you can just add them to your network address. So your network address, the first network address add with 64, it become .64. And then you add another 64, it become .128. And then you add another 64, it become .192. Okay, so if you add another 64, it become 256. So we don't have 256, we have until 255. So the maximum number is .255 here. Okay, so now you have completed your subnets here. Okay, so we have these 4 subnets and it become /36 network. Okay, so it's not that difficult. Okay, so anything in the middle of the network address and the broadcast address. So the broadcast address is basically one number before the second network, and the usable host range is between the network address and the broadcast address. So this is all the networks that you have in your subnet that you have in your network. So let's take a look at your second exercise here. So here we have host address 192.168.1.23/16. Okay, so you need at least 32 subnets with 2024 usable hosts each. So this is quite a lot. So I'm jumping in immediately to a lot of networks, subnets, and a lot of hosts. So I think you can understand this, okay, based on what we did before. So basically you have this host address, okay, and then you have this subnet mask. So you need to find out the network address first. So as usual, get the binary, and you end the binary, you will get the network address. As you can see here, because the subnet mask is only 2 octets here, okay, your network address only 2 octet as the network portion. So you got another 2 octet for your host portion, which is equal to 16 bit. So this one is categorized as /16 because of only 16 network portion bits. So let's take a look at how do you get the subnets. Okay, so here we have 16 bits as a host portion. So we're going to borrow at least 5. Why 5? Because 2 power of 5 is equal to 32. So we're borrowing 5 bits to create 5 subnets. So we have to borrow 5 network portion here. 5 bits for our network portion here. 5 bits for 32 subnets. Okay, so you got remaining 11 bits for your host portion. So right now, your subnet mask, your new subnet mask can be categorized as 255.255.252.480. So this is your subnet network portion. So basically, the number of subnet bits is 5 bits. The number of subnet that you have, number of subnetwork that you have is 2 power of 5, which is equal to 32. And the number of host bits that you have is equal to 11. The number of usable hosts that you have, 2 power of 11, subtract with 2 equal 2046. Okay, So this one, of course, one reserved for network address, one reserved for broadcast address for each of these network. Okay, so you can summarize it as you will have 32 subnets with 2046 usable hosts each. Okay, so this is when you borrow 5 bits from /16. So now your /16 will become a /21 network. Okay, so let's take a look at the table here. Okay, so you will have 32 subnets. So here I only put in up until the 4 main subnets. So basically you will have subnet number 1. Okay, start with the original network address. Okay, and then you got .8.0 and .16.0 and .248.0. So how you obtain these values? So basically, as usual, you get the magic number, which is 2 power of 11 equal 2048. Okay, so 2048 is not defined here in the IP address, so you need to divide them by 256, which equal to 8. Okay, so which equal to 8. So in this case, you will add plus 8.0. Okay, plus 8.0. So you have two, because you divided with 256. So the back one defines 256 and the front one is the value that you divided. Okay, so this one plus 8, then you get plus 8 and continue up until 32. And in order for you to simplify it, how do you get up until 32 is that you will try plus 8 times subnet number, which is this one, subtract with 1. Okay, so means that to get the number 32, you just do plus 8 that has been multiplied by the subnet number, subtract 1, which is 31. 8 times 31, okay, you will get, okay, a certain value, okay, and then to 8 times 31, okay, okay, you got 8 times 31, which is 248. Okay, so you have the maximum value as for 255 and 255. Okay, so here, so you got the broadcast address based on the number before. Okay, and the next subnet for each, and anything in the middle is the usable host range. So this is how you get your subnets for this network. So instead of /16 become /21. Okay, hopefully you guys can understand that before proceed with VLSM. Okay, so let's take a look at VLSM. So basically what is VLSM? Okay, so before this, when we did with subnets, we are dividing the networks equally. Okay, so equally. So you have the networks is divided into several networks with equal size. But sometimes, okay, in your own environment, working environment, in your own industry, in your own school, or in your own projects or anything, so they don't require the equal amount of hosts inside each network. So basically what you need to do is that you need to divide your networks according to the number required for each other network as well. Okay, so in this case, okay, you have to divide the networks into a more uneven number. Okay, like for example, I've given here. So you have this network address, okay, 172.16.0.0/23, and you have the requirement here. You need one network for 200 hosts. You need another network for 100 hosts. You need one more network for 50 hosts. You need one more network for 25 hosts. And another network for 10 hosts. And finally, 4 point-to-point networks for 2 hosts each. So it seems like a lot of networks, right? So how exactly do you do it? Okay. So now you have a /24/33 address. So right now, if you look at it, how many number of hosts do you need? So you have 300, 350, 375, 385, and another 4. 385 times 4 times 385 plus 8 is 393. So you need at least 393 hosts, okay, inside your network. So does the 393 fit inside this network address or not? So let's check that first. So this is the network address, and this is the subnet mask. So as usual, look at the binary and try to find the network portion and the host portion first. So in this case, your network portion is 23 bits and your host portion is 9 bits. Okay, so find the magic number here. Okay, so magic number here is 2 power of 9, since the rightmost bits, okay, the rightmost network portion bit is at the 2 power of 9 position. Okay, again, from the right side, 2 power of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 2 power of 9. Okay, so 2 power of 9 is 512. Okay, if divided by 256 is equal to, so your network address, okay, should be from 172.16.0.0 plus 2.0 until 172.16.2.0. So this one we are not going to use because this one is reserved for something else. It's not mentioned why. Okay, we know that our limit of using this IP address is only up until this point. So we can only use up until 172.16.1.255. This one will be a network address for another address. Okay, so in this case, from your network address here and your broadcast address here, so the usable host that you have, okay, and including the network address and your broadcast address is 512. Okay, so you have 512. So total for this network address, okay, you can provide a 512 address available. Okay, seems a lot of address you can put in. Okay, so let's take a look then. Okay, so basically you can put in 512 hosts inside this network. Since we are going to split this network, okay, let's take a look at the value here and the prefix. So you have /23, you can divide it into 512 hosts. Okay, so if you want to split it in half, basically you just increase the prefix by 1. So when you increase the prefix by 1, okay, you got 172.16.0.0/24. Increase the prefix by 1. You got a 256 hosts here, and you will get another subnet here with 172.16.1.0/24 with 256 hosts. Okay, this one you split into 2 by increasing the prefix. Okay, so here, okay, starting with this value plus 256, you will get here 1. Okay, because 256 divided by 256, you got 1, and when you add with 1 here, you got 172.16.1.0. Okay, so here, so this 256 on the top here we reserve for the first network. Then we will split the network even further for the second network. So we split, we increase the prefix, and we get 172.16.1.0 here with prefix /25, now with 128 hosts. So you have 128 hosts for .1.0 until, okay, you get a second subnet for here is 172.16.1.128. Here is for the second subnet for /25. So now this one we will reserve for this network here, and we'll split the second network even further until we get 172.16.1.128/26. Now we increase. Okay, increase, we split it into another half. Okay, so you have this one for 64 bit, and then you add 64 into here, you got 192. And here you have another 172.16.1.192/24, which is another subnet here. So here we will reserve for the third network, which is 50 hosts, and we continue subnetting the next one until we get this part 172.16.1.192/27, which is have 32 hosts, and you have the second one, which is .224, which is you add 32 to the 192, you got 224 here. Okay, you got the second one. Okay, so this one will reserve for the 25 hosts, and then we split again. Now it's /38, we got 16. The top one reserved for the 10 hosts, and the bottom one we'll split it again, and this time we will split it even further. Okay, so now 16 hosts, you want it to be smaller, you don't want to be okay. If you split it into 8, okay, you only get 2, you need another 4, so you need to split it into 4. So instead of /38, you split it into /30 instead of /29. Okay, so from /38 instead of /29, because /31 only get you 2 subnets, which is 8 hosts each. You split it to /30 where you have 4 subnets with 4 hosts each. Okay, so again, you might ask me, okay, why do you need 4 hosts since they only requested for 2 hosts? You can go up to 2, right? So why not /31? You will get 8 subnets with 2 hosts each. So the problem is that for these 4 hosts, you need to include the network address and also the broadcast address other than the usable host. So basically, for 2 usable hosts here, you need to add the network address and a broadcast address, so it becomes total of 4 hosts. Okay, so now we have 4 subnetworks for the point-to-point networks. Okay, so basically we reserve all these addresses for each. Okay, so this one is 256, 128, 64, 32, 16. Okay, 4, 4, 4, 4. Okay, so I think we have enough for your network here. So let's continue. Let's build up a table. Okay, so let's take a look at the table that we have here. So look at subnet 1. Okay, when you look at subnet 1, you see that it starts with the original network address. Okay, so this is 256 hosts. Okay, so you go up until .1, and then this one, okay, 1 to 8 hosts, it goes up to 1 to 8, and then from 1 to 8, okay, you get 64 hosts, it goes up until 192, and then it goes up 32 until 224, it goes up 16 until 240, it goes up 4 to 244, okay, it goes up 4 to 248, and it goes up 4 to 252, and another 4 up until 25 .2.0, but we don't use .2.0. It goes up until the broadcast address .255. So basically, the broadcast address is the address one before the next subnet, and the usable host range is anything in the middle of the network address and the broadcast address. So basically, this is how you conduct the VLSM for a network. So we have provided in your Google Classroom a lot more exercise for you to try. Refer to this instruction and refer to this demonstration for your practice later on. Okay, so it's easier than, it's not as easier, it's not as difficult as you think. Okay, as long as you can conduct the subnetting first, okay, VLSM will be very easy for you because it's just a subnets within a subnets. Okay, so I think that's all for my demonstration for today. So I see you guys in my next video. So hopefully this will help you in understanding VLSM and subnets. So as usual, I am Dr. Shafiq again. Okay, please don't forget to push the like button and subscribe my channel for more videos on data communication networking. So that's all for today. I see you guys in my next video. So stay safe, stay at home, and stay steady. Bye bye.